So here we have that same terrain in Unity. It's quite large, it's a square kilometre, and you can see I've got roads in the terrain, these mountainous borders on the edge of the terrain. The terrain's all textured and there's objects scattered all over it, such as rocks and logs and mushrooms. And all of this is procedurally generated. I'm using an asset called MapMagick, which allows you to procedurally generate the terrain based off of a node graph, and you can also scatter objects on that terrain. There is some catches with that and performance costs, so there's been some workarounds that I've incorporated into my workflow to maintain a workable frame rate in the editor and also in the final game. Alright, so here we have the node graph, and this is as far as I can zoom out, and I can't show the whole graph unless I pan through it. So it might look intimidating, but it is fairly organized. Each one of these blocks is a different thing. So like this red one here is a bunch of nodes that create the mushrooms on the terrain. This brown one here does all the twigs and branches, and a lot of these groups of nodes are using the same handful of nodes each time, such as spreading, scattering, adjusting, and masking. The downside of having so many different types of objects scattered on the terrain is that MapMagick itself can become quite slow to work with. So before we do any of the objects, usually the first step is to create the terrain itself. And the terrain itself is made fairly simply. It's just this handful of nodes here. When you're creating the terrain at the start of the process, it's actually quite performant to tweak these and get the right amount of rolling hills that you're after, and then you can erode those hills to make them look more realistic. So a quick overview on how the MapMagick tool works. To create a terrain, you just right click, choose 3D objects, MapMagick, and that'll create your MapMagick object, and you can see that error in the console saying that a graph is not assigned. So we just need to assign a graph or create a new one. Here's my one that I was using earlier, so I'll just drag that in. You can see that's instantly kicked off and started to generate. So what we can see here is the draft terrain. If we open this up, that's our draft terrain here. And once it's finished generating the terrain, it'll disable that one and we'll see the main terrain. Now, my terrain takes a little bit to generate because it has so many trees, objects scattered all over it. But you can see that's finished now. And now we're looking at the main terrain. If we click this little folder here, it'll open up the node editor, which looks like this. And as I was saying earlier, we've got quite a few different systems here. And if we make any changes to these nodes, it'll instantly want to regenerate the terrain. And whilst that's happening, we can't make any changes. So it can get a bit annoying doing that. So what I generally do is, if you select MapMagick and scroll to the bottom of this window, you can see under multi-threading, instant generate. If we toggle that off, any changes that we make to the graph won't trigger a rebuild. If we do make changes and want to regenerate, we can just click this little button up here and that'll kick off. So the reason the performance is quite chuggy to work with is because of the amount of nodes that I have to make up all the objects on my scene. And although it's quite organized visually and doesn't look like everything's interconnected, you'll notice if I zoom in on, say, the birch trees here, pretty much every group of nodes here I've organized to an output node. And then you can see something like the twigs and branches uses inputs from the pine trees and the giant trees to then decide where to scatter twigs and branches. So each node has a little drop down which allows you to see a preview of the locations. So if I click this little arrow in the top left corner, we can also get that to preview on the terrain itself, which is quite handy when you're trying to debug when things aren't appearing where you expect them to. So looking at this graph, we're combining the location of every giant tree and every pine tree, and that gives us 3,500 positions. And then we, using a spread node, are spreading more position points anywhere between 1 times and 3 times the amount at a distance of anywhere between 10 and 15. So that, you can see, bumps it up to 7,000 positions. And then the adjustment node here just puts some variation on the prefab that we're going to place. So it'll rotate between 0 and 360 degrees on the y-axis. It'll scale between 0.9 and 1.1, and it'll move it up and down anywhere between 0.2 and 0.5. Those values were just a bit of trial and error to get the logs to look like they were a little bit in the dirt and not floating above the terrain itself. And you can see we output from this to a portal called logs, which I'll get back to in a minute. But lastly, we then mask using the roads and under the large rocks to basically just remove points where there are roads or large rocks. So that's why we go from 7,000 objects down to 6,500. Then lastly, we just connect whatever prefab we want to spawn on these positions. So in this case, I've got 2 different log types as well as a tree branch, and I should really have this point connected to my portal. So these final position data points go to the log output, and if we move over to the mushrooms, for example, they take that data. So that would be the same as connecting directly to here. It's just visually a bit cleaner to have it go via a portal. But we basically spread from the log positions, do the same sort of adjustments, and then that output is masked again, so we don't get mushrooms spawning on our cliffs or under, that's under large rocks again. And then, yeah, we've got different prefabs spawning on those positions. So you can see we've got 6,500 positions for mushrooms. So if we look at our scene and we go hunting for a log, like that's a log there, we should see mushrooms somewhere around. Here's another log. No, not seeing a mushroom there. So this is where, if we go back to our mushroom mask node here, we could press this arrow and that'll show the positions of where those mushrooms are. So we can just visually navigate to one here. So here we go. There's a twig that's scattered and there's a mushroom. And if we go into this long grass, you could probably do without these because they're pretty hard to see in the long grass. But if we go, here we go, here's another little mushroom. So yeah, lots of probably over the top detail here, but it all sort of adds to the realism of a forest. So if we want to toggle that off, we can just press that little arrow again. That'll toggle off those little chevrons. You can only have one of those active at a time. So another feature of Map Magic is you can have the objects that you spawn on the terrain affect the terrain. So you can see here we've got this massive rock and it's actually texturing the ground beneath it with that sandy texture, because I didn't like the look of having grass everywhere. And you can see these larger rocks are spawned around the massive rock, and they too make the ground beneath them sandy. So just looking at our graph, this section here is what creates what I've called massive rocks. And we can confirm that again with this little down arrow at the top left, which shows the little position marker here. So I can tell that's a massive rock. I made a section up here called texture under rocks. And you can see here, we use the output from massive rocks, as well as large rocks, medium rocks, and small rocks. And we're using this stamp node. You can see here, this is a noise node. You can use this bottom right button to toggle between colored or black and white. Usually I find black and white is easier to read. So this is just pretty much just adding a randomness to the stamps. So the stamps will be basically a dot, and this value here determines the radius of that dot. So the massive rocks have a 20-meter radius, and there's some randomness in that, so it's not a perfect circle, which results in this nicer sort of blending of the shape with the existing texture beneath it. So just going back a step, so we've got all these blue portals, these texture outputs. So if we go to our texturing section, you can see here, this is the sandy texture that we're using. And if we just go and grab this node, you can see it's not that one. I haven't quite organized this part of my graph that well. But you can see here we've got all of those under massive, large, and medium and small rocks. All those outputs are blending together and they come into this texture node. This texture node is pretty much like a Photoshop layer stack. So you can just add as many layers as you like, and whatever's on the bottom will get painted over with whatever's on top. So I start with making the terrain all mud and then putting pebbles on it based on whatever nodes are connected. And you can use your terrain's height data that we created in the first step up here. So that you can see I've used an output node called height. And then that's used on a lot of these nodes here. So we've got height here connected to all of these nodes. And this step here of doing the texturing is quite performant as well. Before you've placed all the objects, it's only later on, once you start doing objects, that you then come back and add more layers on top for texturing under objects. So a slight performance thing you might have noticed here is I'm blending these portal outputs together here to go into my sandy rock texture there, but I'm also doing it up here as well, and its output is called all rocks. So there's never a point doing that twice. So what I could do is, holding Control and Shift, you can make a selection box. So I'll just grab all these nodes like that, and then to delete nodes you can just drag them up into that remove. You can see each change I do does require it to reevaluate all the nodes. Even though it's not regenerating the terrain, it can still get a little bit slow to work with once your terrain gets to this size. All right, so I just paused it there. That took another 10 seconds or so. But now I'm going to grab the output of all rocks. So to create a node, we just right click, and that brings up this little search window, and we can just search for what we're after. So it's called a portal. So just start writing portal. You can see here we've got portals. We want an exit portal, and then the drop down will let us choose all the nodes that we've created. So I think I called it all rocks, and then we just connect it to that texture slot. Now, if we wanted to verify that that change worked, we just hit refresh up there, and you can see it's regenerating. It seems to take around 10 to 15 seconds. There we go. So that's regenerated, and if we navigate to our large rock, you can see we've still got the do we still have? Yeah, we still have the sandy texture in the base. So we do have a problem here with the rock clipping through a tree, which doesn't look great. We don't want to manually change that. So this is where we want to tweak our graph to see that change. So I'm going to disable auto generate, and we'll go into our graph to find that. So I can tell that that's a pine tree. We basically want to make sure a pine tree is not spawning within wherever this large rock is spawning. And the large rock, the distance is calculated from the center of that prefab. So you can see it's already a meter away from that large rock. But we'll go in and adjust that. So first off, I'll just confirm that that is a large rock just by going to my graph here, navigating to my rock section, and just enabling this little tick box here up the top left, and just looking for, there we go, it's that one there, because on my other screen I can see that, yep, there's a little chevron indicating that that's the object that's getting spawned. So I can disable that now, and I'll go to my pine tree, which is down here. So I know that pine trees are getting scattered and we need a mask for large rocks. So you can see we already mask out where the roads are, but that is using 2D information because all the texture nodes are blue, all the objects are green. So we just need to mask the 3D objects, which is called a rarefy node. You can see I already have one here, so it's rarefying the spawn locations for wherever there's a giant tree. So we can just add to this, and I'll just create a new portal just by right clicking, and it's just re-ticking. And there we go. So I'll just create a new portal, an exit portal, and we may as well use, I think we have one for all rocks. No, we don't. Well, we'll just use the medium rocks for now and hook that in there. And you can see we're currently at 3,600 position points. So hopefully that reduces it. So after hitting refresh, I did just have to retoggle instant generate before hitting refresh. So the reason that didn't quite fix it is because if I look at my graph here and just zoom in, so toggling this little chevron here helped me see in the scene view that I don't actually have a position marker for that tree appearing where this rock is. It's not until we then spread that we are getting a position marker for that tree near that rock. So all we need to do is do our spread and our mask, and then finally do the rarefy. So to do this, what I'll do is just come back to the scene and toggle off my instant generate on my terrain to allow me to make changes with a bit less lag. But basically we want the rarefy to happen here and the spread to happen first. So I'll connect the spread, and then from the mask we'll go into the rarefy. The rarefy will go into our spawning of our trees, and at that point we'll go into our portal, and then we can move these back up here, make it a bit clearer to read. Our rarefy nodes, if we hold Control and Shift, we can group select, move them down here. We're combining the output of that into a portal called All Pines, because that's combining our other pine trees down here. It's a bit easier to read there now. And I think I made another portal here called Additional Pines. So we've got pine trees large and additional pines. So now if we come back to our scene view, we can choose to instantly regenerate, and then I'll just hit refresh. There we go. It's finished generating our trees, and you can see we do have a position marker there, but we don't have a tree. And that's just because I still have this guy enabled here, which is showing all the positions, but then they will get culled out If we click on the rarefy, you'll see in the scene that point's now disappeared because it's been masked out basically. So one thing you might find once you get so many objects in your scene is the little preview nodes here. You can see this section of the terrain isn't actually generating nodes, and that's just hitting the limits of how many objects this node can handle. So you can see it almost 16,000 objects. It seems to not be able to spawn anymore. But then the mask is reducing that down to 14,000, and then the rarefy is dropping that down to 10,000, which seems manageable. The reason they don't go all the way to the edge is because I've already set my mountains earlier to be part of the mask. We don't get trees right on the edges of the mountain because I had my mountains snow covered. So it might seem quite slow to work with, and it is at this point to make changes to work with the tool, because you get that Unity tick where it can take 30 seconds to unfreeze to allow you to make changes. So I did find some other workarounds. If I pop back to the node graph, you'll notice that things like the trees, originally you can see they all come from the same node here, which is called scatter 300. And I basically made this group up here called new call trees. So this is using a scatter node, which just randomly distributes points across the terrain. The density used to be 300. I've put it up to 750 now, so I guess this should really be called scatter 750. But by having this run into a portal and then using that portal multiple times, we reduce the amount of scatter nodes we would need. But I also have the ability just to disconnect this one connection here, and once this refreshes, that'll generate my terrain with no trees. And because I have no trees, I also will have a lot of objects not spawning, because a lot of the objects, such as the twigs and branches, require the inputs of the tree positions. So by nuking that one connection up here, we kill all the trees, a lot of the twigs and branches, and therefore mushrooms. So that can be a quick way to kill a large group of objects from spawning to allow you to work on other objects, like, for example, the rocks. So that's how I managed pretty much just toggling on whatever thing I was working on at the time to allow faster generation. So you can see here's that end result. You can see already that the editor is a lot smoother to move around and fly around in, because all we're generating is the terrain itself, and then in this case a handful of massive rocks. I think there's about 300 placements across the scene, as opposed to thousands or several thousand trees and rocks and twigs, etc. For doing something like that terrain painting beneath the objects that we talked about earlier, it's a good idea to be able to kill everything else, just so we can have faster iterations on getting that part to look right. I've just spotted another bug here where I've got pine trees coming through our massive rock. What I'm going to do is create a combine node, which allows me to combine several position data into one output. So I'll make a portal as well for this output. In this case, it'll be an enter portal, and we'll call this all rocks. And you can see it's quite challenging to work with at the moment, but we'll go our massive rocks, our medium rocks, and we can just add more to this, because we also want our small rocks. Again, it's just ticking. And then I think I have a large rocks up here, so this is going to get a bit of a spaghetti mess, but that's not too bad. So now we have an output for that called all rocks, which is what we'll use down here for rarefying our pine trees rather than just the medium rocks that we did earlier. I'll change that to all rocks. And we should see that number should drop down from 10,000. Just popping across to the scene view here, you can see when we generate those rocks and twigs, they all get put into this objects folder, which is quite a massive list. And I found shift selecting these and choosing delete can cause Unity to hang because it's literally like 38,000 objects. But when I was creating my own script to combine objects together, I created a delete button which deletes the children object of whatever game object is selected. So I'll just add this now to my object group. So this is a custom script I was writing to combine objects together, and I have this button here, delete all children. So this will delete all the children of whatever game object is selected. So just with one click there, that should nuke all the trees will stay there, but all the rocks, twigs, mushrooms, etc. will be deleted. You can see they're still there in the scene. If we select that, you can see here, that's because they still exist in this map magic object. One bug I found with map magic is sometimes you get duplication of some of these elements. So there shouldn't really be two objects. So what we can do is delete that one. We'll add my script to this one and press delete again. I'm not sure why it duplicates that, but you can see now with all those objects gone, we're back to a nice fast editor. If in deleting that group of that object, you get errors in the console, you can fix that by changing to debug mode, and you can find a reference to that object. So it's just under the tile, and you may lose this reference here to the object pool, which is just the objects folder here. You can see object pool script there. So with that reconnected, we should be able to turn off debug mode, tick our instant regenerate and hit refresh. Let's give that a second. I think it takes about 10 to 15 seconds to regenerate the whole terrain, which seems like a while, but it is still faster than hand sculpting this terrain and scattering objects and placing things. The good thing about Map Magic is it still uses the Unity terrain system, so we can do that. Yeah, if we do want to like draw in our path or change and paint out more trees, we still have that ability. Of course, if we regenerate the terrain, we would lose those changes. So I try to do as much with the node graph as possible. So with that little position display marker button ticked, you can see we're still getting trees appearing in our rock. And that's just because our massive rock here has quite a large radius. So we may need to make a special rule because our rarefying a distance of 1.5 meters from the center of all those rock locations. So in this case, we get a tree here because the center point is probably here for this massive rock, and 1.5 meters is still far enough away from the center. So I'm going to quickly make that change, and I might do it on a time lapse, and I'll be back in a sec. Alright, so that seems to fix the problem. We no longer have the trees poking through this massive rock here. So just go quickly through what I changed. At the start here, where our spread node here was set to 10 and 15, I reduced that down to 5 and 10, which makes a lot less position points. So you can see these now no longer have trouble filling the whole preview there. This safe board is here, by the way, is how I reduce the position data appearing on the very edges of my tile for my surrounding mountains. I cleaned up the general nodes and I added a additional rarefy node here, which I put between the original one. So you can see we've got massive rocks coming in with their rarefy distance of 20. So basically 20 meters from the center point of this rock, there shouldn't be any trees. And you can see if I toggle the position data for our final rarefy output, and the top down view here, you can sort of see all our pine tree positions. And you can see there's none around that massive rock. And then looking at our rock collection here, I basically removed the massive rocks from this combine node and moved this down here just to make it a bit more organized. So now we're just combining our small rocks, large rocks, and medium rocks into our node called all rocks, which we could probably rename, but that's fine for now. So there you go. That was quite laggy to work with. You can see it took me a few minutes to actually make those changes, but the end result is still better than doing it manually. And another thing I found is all these little preview windows on these nodes seem to impact performance. So generally try to have them closed when I'm not needing them. So now that we've got our final terrain made, painted, objects placed, and we're quite happy with that, you'll notice that you've got thousands of objects in this objects folder, and that's not going to be great for performance. So what we can do is combine those objects together into one major object or several larger objects to reduce the amount of draw calls. Now, I spoke earlier about a script I was writing to handle this, which did work, but once the objects get up to crazy numbers like I have here, I think I have almost 40,000 objects, it was getting too slow to run through and combine them. I might still publish this as a free little script for smaller scenes, but it was taking upwards of 30 minutes to run through, so there's obviously some optimization that needs to be done. But instead, I was using an asset called Mesh Combine. So Mesh Combine allows you to combine meshes together, and all you have to do once you have the asset installed is get the Mesh Combine prefab, Mesh Combine Studio, and drag it into your scene. And then with it selected, you get this panel on the right here, and there's quite a few options, and it looks a bit overwhelming, but it's quite easy to use. First, you just drag in the parent object of what you're trying to combine. So I'll grab my objects folder. I want to combine, I'll just untick static because I want to combine pretty much everything that's active in that parent object here. And then we can pretty much leave everything default. One thing I'll change here, and this is just from my own trial and error, is putting this cell size up to 300. So that'll basically make a 300 meter grid and combine the objects that share the same material in that cell as its own object. If we scroll down further, we can find these 4 buttons here. So we just hit search, and you can see that's found 67,000 objects. Before I had 38,000, so I think something's possibly gone wrong where I have multiple objects on top of each other. So I'll just confirm that by grabbing this log here and just moving it. Oh no, that seems all right. Sometimes with Map Magic, I found that you can get the objects not deleting between refreshing. So that's just one thing to keep in mind. You'd get duplications of the object, but it doesn't seem to be the case here. It is cool that you can, these are just objects in the scene, so you can move them manually if you don't want to correct your graph to make rules. But of course, any changes you do will get overwrote next time you regenerate the terrain. 60,000 objects is quite a lot, but with that amount found, we can hit combine, and you can see that only took barely 3 seconds. And you can see here we've gone from what would have been 67,000 draw calls down to 400. You can see if we open up the Mesh Combine Studio, we now get a cells folder, and you can see with the value of 300 that we set, we get about 20 cells. And if I just select one of them and hit F, you can see here the size of that cell. We select the next one. You can see it's basically made these grid cells of collections of objects. I hit F to focus on that one. And that's really cool because then we can toggle these on or off with either camera frustum culling or based off the player's position, so that if the player's not in this area, we don't even bother rendering that group of twigs and logs. And with such a dense forest, you probably wouldn't even notice if you were standing here, the amount of trees that are going to occlude those objects. So that's something we can do to increase performance down the track as well. So now that we've combined those objects together, our next step is to delete the ones that are still in the objects folder because they're still there. So with our delete all children, you can see now we've got an empty objects folder, but we still have the objects in our combined group. So now if I select this rock, you can see it selects all those connected ones. So if we save the scene here and just look at the size, originally our scene was 10 meg. And if we refresh now, we should see that increase to around 700 or 800 meg. Oh, there you go. You can see there our forest scene is up to 1.3 gig. Now, the reason that's so big is because all the mesh data of those combined meshes is contained within this scene. So what we can do is go to our assets folder, create a folder called combined meshes. I'll just delete this one I made earlier. And create a new folder. And this mesh data is going to be unique to this scene. That's why I just created a folder in here. And with Mesh Combine Studio selected, we can choose, we scroll down, Save Combined. Navigate to that Combined Meshes folder and save the data in here. Okay, that's done. So now we have a folder for all those meshes, and you can see if I select one of these, you can see there it is. It's a group of rocks. It's another group of rocks. And now we just grab the parent game object there and just drag that into that same location, which will make a prefab. So now if we save the scene and look back at our project and refresh, there we go. So now our scene's back to 27 meg. And if we do a full refresh on our project, and if we just go into the combined meshes folder that we made, so you can see here, we've got 2.5 gig of mesh data. When it comes to version control, I'm going to ignore this folder because there's no point keeping this on the repository, as any changes I do to the terrain will require me to regenerate, recombine, and then save out these files again. So I'll exclude that to save on my repo size. So that's basically my workflow for creating a procedural terrain in Unity. And if I did want to change anything, for example, if the scene was running too slow, I could delete this prefab. There's a lot less objects for the editor to draw. And then at any time I can just drag that back in, and as long as the terrain hasn't changed, it'll all be in the correct position. If I do want to make a change, I can just delete that prefab. I can delete it out of my scene. I can delete all of these objects. Choose Map Magic, make sure instant generate is set. Use the little refresh button up there, or you can also just hit generate up here. That'll regenerate. I'll have a bunch of objects under the objects folder for all the rocks and trees and sorry, not trees, but twigs and mushrooms. And then using mesh combine, I would just hit search and combine, and then save out the selected objects, create a prefab, and then using my little script button here, delete all the children from the map magic object. The paths here that go throughout the terrain, they're done with the orange path nodes here, so they can be used to make roads or rivers, and that's something that I want to expand upon at a later date and have some flowing rivers through my terrain. The good thing with map magic river nodes is they tie in well with the RAM asset rivers to allow you to have water running down the rivers, so it's definitely something I want to add in at a later date. The one issue I've got here is the grass doesn't seem to be standing upright. You can see it looks like it's blown over. I'll just show you how to fix that. So this part of my graph is what makes the grass. You can see the grass is all set to be the grass mode rather than billboard. Billboard will rotate the grass pieces to always look at the camera, which can get a bit weird. So these are my different colors for the grass as well. And you can see these nodes here are just blended together to reduce the location of the grass so that it doesn't spawn grass on the roads or on the cliff walls or under large rocks. So here we are in play mode now, and you can see we're getting around 30 frames. When we actually do a build, my frame rate goes back up to over 60. So just looking at the playback here, we're getting these errors just because our characters on the terrain was out of Navmesh. But in terms of that grass, I just wanted to check that it's doing that all over the terrain, which it is. So it looks like we just need to lower our wind turbulence. So that's quite easy to do. We just go into our map magic object, grab the main terrain, and go into the terrain settings here and just scroll down to wind and lower the bending here. You can see as I dial that back, our grass doesn't bend over as much. So now if we enter play mode, you can see here our grass is looking a lot more realistic. Okay, so lastly, we just want to create a Navmesh over our terrain. The reason our player looked a bit odd before was because I had that set to center. So make sure that's on pivot, and then holding Control and Shift, we can move him around the terrain, and you can see he'll be placed on the terrain. But we want to make a Navmesh on this terrain, so that's easy to do. We just grab our main terrain object, and I've upgraded to Unity 2022, which changes the way the Navmesh works. So now we have to add a Navmesh surface, and we can hit bake, and you'll notice we get this new UI down here. If I tick that box, we should be able to see our Navmesh. If I enable the gizmo up here. I'm not sure why I get these grids. It seems to be a result of one of the combination of assets I'm using. I'd see this happen in other scenes, but it is what it is. It's still sort of visible. You can sort of see here we're cutting around that steep piece of terrain there. It's inaccessible. But one thing which is unfortunate is we can walk straight through our trees. There's no avoidance around those tree objects. So to get our terrain to basically cut around each tree, we can add a game object and add a Navmesh carver onto it. but we want to do that for every tree and we don't want to place them manually. So I created a script called extract tree colliders from terrain, and adding this script will automatically add the Navmesh surface. But if we open up this, we also have a little field here to define basically an ignore list if we want to ignore certain elements. But with those just set as empty, we should be able to hit create Navmesh colliders from terrain trees. And you can see here, if I just hide the Navmesh, you can see we've got a collider capsule made from the collision that's in those tree prefabs. So now if we go back to our Navmesh surface and hit bake, this will take a couple of seconds, but you can see now we cut around all of those trees, so our players won't walk through the trees. Where this doesn't quite work is with larger trees, such as this guy here. If I turn on the Navmesh, you can see that the cutout is a bit bigger because his collision mesh is bigger. But using my node graph, I really overrode the scale of this tree. That's why I have this field here called custom scale list. If I just navigate to my tree prefab and I just drag that into my custom scale list, I can override with a multiplier of 3 and hit regenerate, and you can see if I toggle that off, you can see I get quite a large collision volume. So maybe 2 is big enough. Every time you hit create new Navmesh colliders from tree terrains, that's hard to say, but it deletes the previous ones. Now you can see that's a pretty good size capsule for that tree, and then we can just rebake our Navmesh and just enable that, and you can see that's a lot better size. Just move over to another giant tree and make sure that it works for all of them. So you can see this tree is even a little bit larger. If you look at the Navmesh, that's still pretty good. Our players are not going to intersect with that tree too badly. And then once we've done our bake, we can just hit delete all children. And there we go, that deletes all those temporary colliders. So now if we just go into play mode, we should be able to walk around our terrain. So back in play mode here, you can see we can't click on the tree because it's not, there's no Navmesh there. And if we click on the other side of it, the player should walk around the tree rather than move through it. So there's not that many steps to make changes and regenerate everything. The difference is quite noticeable when you toggle off all those ground assets like my rocks, and we still get some twigs because they're being spawned as trees. If we look at the main terrain object and we go to its tree value here, you can see we're spawning twigs on the ground. The reason I put them in with the trees was because of improvements in performance, and also I don't really want the twigs to act as collision. So if we look at our Navmesh surface and turn the gizmos back on, you can see that the twigs don't actually count towards any collision data because they don't have a collision mesh in their prefab. Benefit of that is that the twigs won't affect the player's movement. The downside is the player will move through the twigs, but they are just sort of background elements. Having the rocks in their own group as game objects means that I can still use them as collision data, and with them in the scene now, if I redo the Navmesh bake just by choosing the Navmesh surface and hitting bake, even though we combined all those rocks and logs together, we still maintain their collision mesh data, so the player will be able to walk on rocks that aren't too steep. You can see here the larger rocks get cut out from the terrain, but we did, in redoing that bake, lose our tree objects, so we can just hit our create Navmesh colliders, redo our bake with them enabled. And then after that's finished, we'll just hit the delete all children to remove these temporary colliders. There we go. So that's a overview of some of the tools and systems and combination of them that I'm using to create this large open world scene. If you have any questions, please leave them in the comments, or if you know of better ways to do any of the things I showed here, please let me know. I'll hopefully have my own game out for wishlist soon, so if you're interested in that, make sure to subscribe, and I'll see you in the next one.